Okay. So you guys were working through your warm-up, and then I had you guys like starting on the back. Let's take a look at the transformational graphing stuff. And we've got here the quadratics. No, quadratics will not be part of this lesson, but it gives us an easy chance. That's usually not a function that people kind of like go, oh my god, I don't remember how to graph it squared. So we could focus on just the general rules. Hopefully you saw that number 1 was the parent function. Okay? And if you don't remember the parent function, you can just plug in numbers. 0 squared is 0, 1 squared is 1, 2 squared is 4, yay, I can count, 3 squared is 9, and then the negatives do the same thing. So if you've forgotten your parent functions, that's one that's easy to kind of figure out. Greatest integer, step functions, not so easy to kind of figure out on your own. Okay? Plus 3 does what? Moves it up 3. Plus 2 moved it to the left 2. And then for this guy, if we think about our starting place moves right 3 and up 1. A negative on the outside. The outside is going to flip your graph in the vertical direction, so over the x-axis. Okay? How are we doing with those so far? Just a little bit, simply because we are going to be doing some work with exponent graphings, and we're going to do a lot more with logarithms. If you haven't figured it out, because you know the title of the unit that I gave you on the piece of paper that spells everything out, we are doing exponents and logs here. It is kind of a longer unit, but it's okay. Okay, and remember, we are fresh. Okay? You are all starting from a very clean slate. It is like you are in a brand new class, but you've already gone over the growing pains and you've gotten used to it. You can do anything that you want this quarter. No previous material. Do you understand that? I think it's very important to understand that everybody has a clean slate. That doesn't mean, hey, I got an A first semester, I'm going to get an A second. It doesn't mean, hey, I got a D first, I'm going to get a D second. Anything is possible. Okay? It's the beauty of this. All right, 5 and 6 were the ones I was the most worried about. 5, the 2 was on the outside. And for the outside, you can see here where my parent function points were. We multiply the vertical height by 2. So we would call that 2 a vertical, because it's going up and down, and we are stretching it. So when you pull out, it's a stretch. When you push in, it's a compression. Whereas on this one, 2 inside affects left and right, and we do the opposite. So the opposite of timesing by 2 is dividing by 2. So instead of over 1, I'm over a half. Instead of out 2, I'm out 1. Instead of out 3, I'm out 1.5. And what's really cool about the squared is, what does it mean to square something? Multiply it by itself. So that's the same thing as saying 2x times 2x, where 2 times 2 is 4x squared. So what's really cool about this parent function is a 2 on the inside is like a 4 on the outside. So if, again, we looked at this point here, I could either pull it in a half, or I could say times 1, 2, 3, 4. This is a really cool kind of thing that you can work with that. Did anybody's brains go into shock from that? We okay? All right, the next thing that I asked you to do was I asked you to take a look at the back piece. And I'm still going to give you more time to do the back piece, but I just want to put this up here for you as well. Now, this here is technically from our summer assignment, but we hadn't really been doing anything with it, so we're doing a little bit of a review on it today. These are all of your exponent rules. If you don't remember your exponent rules, it'd be a good thing to write down. What I'm asking you all to do is to work through those, 13 problems, and see what you can do without my help. Our only goal for today is to get through these 13 problems, and then I have a worksheet that is both classwork and homework. Okay? This is all about practice. Next class, you will be taking a quiz over exponents. Because in order to kind of move forward with this unit, I have to make sure that you guys are up to par with the regular old exponents. All right, so keep on working, doing those 13 problems. You're welcome to work together to ask each other questions. Again, star the ones that you're just going, and I promise you we will go through every single one of these problems. All right, we're going to go through these. Some of these will work quicker than others. Some of them take a little bit more explaining. That's okay. And guys, if you ever, seriously, if I'm going too fast, let me know and I'll slow down. I don't know if I can go faster because I'm kind of limited. Not that I move so fast. Hee. No. Euler. Ah, well. Yeah. Yes. Okay. Now, I have one general approach to all exponent problems. My goal is to always try to make things as easy looking as possible, simplified as possible, before I make them any bigger. Because to me, I know where my mistakes are. So I look at this and I say, okay, to make this simpler, I'm going to deal with what's inside the parentheses. And I'm going to combine what I can combine. So if I'm looking at inside the parentheses, c to the 5th over c is going to give me what? C squared. Top or bottom? Top. D to the 3rd over d squared? Top or bottom? And what's in the bottom? 1, which really isn't necessary. Then when you think about that 1/2 is still a power that gets distributed. And what will I do to the 2 and the 1/2? One more time. Add, subtract, multiply, divide. Multiply. Because if we see here a power being raised to a power, that multiplies the exponents. So 2 times 1/2 is 1. And then what power does the d have again? 1. And 1 times 1/2 is 1/2. And so you can either write your answer like that, or what is another way to write a fractional exponent? A root. That denominator ends up being the root. So that is the square root. Either one of those are perfectly fine. Okay? The only time I would ever get picky with this is I would say if I wanted fractional exponents, that's the way that I'd like it. If I'd like it simplified using radicals, that's the way I want it. That's the way, I want it. No? Okay. All right, for this next one, again, I try to make it simpler before I make it harder. Is there anything I can do on this inside portion here? Nah. So it's your choice whether you deal with the negative and the 3 together, just the negative, just the 3. I'm going to take it one step at a time. What does the negative do? Flips. It does the reciprocal. When I taught Algebra 1, they called that the reciprocal. I thought it was funny too. I thought it was like, oh, cool, yeah, it's a reciprocal. All right, then what do I do with these two numbers? Multiply. So that's q to the 9th. Good. Over p to the beautiful. Do I simplify 9 over 6? Nah, not at all. Okay? 3 has a whole lot of something going on. First off, no variable, it's a number. Second, if I have a negative. Second off, I have a fraction. A lot. I'm going to start with a negative, because that's, to me, the easiest thing to do. What does a negative do? It flips it. So I will have 1 over 64. Now, 2/3. What do each of those numbers do? What does the 2 do? The 2 squares. The 3 takes the cube root. It is, I'm sorry? What else would I do it to? because anything 1 is going to be 1, and the negative only does the flip. So wherever it would just flip. Now with this, it comes, all right, what should I do first? How many of you in here want to square 64? And then find the cube root of that? No. Not me. What's the cube root of 64? 4. You okay with that? That to me is a lot easier to find than whatever 64 squared is, finding the cube root of that. You're like, oh, heck no. So the cube root of 64, I always make my problem simpler before I make it harder. I make it smaller before I make it bigger. And therefore, what is 4 squared? So far, so good? The biggest challenge that people face with exponents is don't let them get under your skin. People look at problems, like for example this one, and then they freak out. Or they try to do it all in one step, and that is where things go wrong. Just take your time with it, one step at a time, please. Take your time, please, and it'll be a little bit better. So you can deal with this in multiple ways. You can either think of this as the cube root of 27, a to the 6th, or you can think about this as 27 to the 1/3 a squared. Do you understand what I did? They're both exactly the same. Either way, what is the cube root of 27 or 27 to the 1/3 power? 3. If you're doing a root, you would say 3 goes into 6 how many times? 2, which is what we had from over there. So either way, you should end up with the same answer. Exponents are awesome. As long as you're doing the steps correctly, you can really do them in whichever order you want. Just try not to mess up. So looking at number 5, what can I do to make that simpler? What's my first challenge there? Well, it's not get rid of the top. It's not really distributing even. It's dealing with your parentheses. You want to get a little careful because distribution generally means just straight up multiplication. So here we're talking about dealing with that power. So if I talk about just that piece, for this part, what will I have? A to the 8th, b to the 12th. What will I have for this portion? Beautiful. A to the 10th, b to the 5th. Now, some people choose to just do all of this in one step. Again, understand where your personal mistakes are. I like to take it a little slower and to combine across each level. So I would have a to the 18th, b to the 17th. That way I can focus on one rule at a time. A to the 8th over a to the 7th is going to be a to the 18 over a to the 7 is a to the top or bottom. B to the 17 over b to the 19 is b squared on the bottom. Beautiful, folks. He said, all coming back to you now. Am I like upping my level of weirdness? Fake it till you make it, folks. All right. Now I recall from your summer assignment and from your summer assignment assessments, you guys had a lot of trouble with reading instructions. Okay? You got to pay attention. When I say a rational exponent, you cannot see that. When I'm saying a rational exponent, what am I looking for? Fractions. Rational numbers are fractions. That means I don't want roots in these problems. I only want fractions. So what root is this? That's the square root. And if you want, you can think about that as what power? 1/2. Remember, negatives move position, fractions become radicals. So then I just would work through. 7 times 1/2. That's just 7/2. What will S be to? 5/2. As weird and funky as it sounds, that's a fraction exponent. That's a rational exponent. What will T be to? 12. Give me 1 second. All right. So if I'm looking at this, if you would like to take the step and to rewrite this as an exponent, what would your exponent be? 1/4. Okay, so you could think about that as being raised to the 1/4 power. 16. The 4th root of 16 is 2. Good. If you have trouble, and guys, there's nothing to be ashamed of. To me, I'm great with the letters. I'm like, give me math with letters any day. You put numbers in it, and then we're back to middle school, and for some reason I can't add, subtract, multiply, divide to save myself. So if you have trouble with this, you can always think 2 times 8, 2 times 4, 2 times 2. So all of this together is 1, 2, 3, 4 2s. And 4 to the 1/2, or 1/4 is just 2. Okay, so you can always break those down. It's okay. Then I would have S to what power? 3rd. Good. I would have T to what power? 15/4. Beautiful, 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 beautiful math. Are we doing okay? Not getting much hollering, so I'm hoping that these guys are fine. But if you've got questions, the only way they get answered is if you ask them. Okay. This is where folks had a little bit more difficulty. Using radicals. Does anybody remember what I had to do first in order to write this with a radical? With one radical. Yeah, we need a common denominator for all of our exponents. So, what would the common denominator be? 4. So x to the 3/4 stays the same. Y would be to the 2/4. So 5 doesn't have a fractional exponent, so he would come outside. What root would I have? Because a radical is a root. And then underneath the radical, I would have x to the 3y squared. Now, I'm going to be honest with you guys. I was looking at some of the other teachers and what they were expecting to see with this. I thought it was a little ridiculous. But when it said write the expression using radicals, they shoved the 5, they shoved the 5 underneath as well. And if I put the 5 underneath as well, what power is that 5 going to have? 5 to the 4th. Because that is 1 or 4/4. I'm not going to ask you to do that, because a lot of times they then say, okay, so now evaluate 5 to the 4th. I don't want to do 25 times 25. But just so that you know how to work that out. I personally prefer that. I've just seen with multiple choice when they've done that. I think it's ridiculous, but I want you to be prepared. Okay? So what do I need? I'm going to go with that one. What do I need on number 9? Common denominator. What would the common denominator be? So I would have a to the 8/12, b to the 9/12. So my answer here would be 12 times which root? 12th root of a to the 8, b to the 9th. If I were to squish the 12 under the radical, what power would the 12 need on it? Yeah, this is again why I don't like that. Not even, okay, just curious. Just curious. Curiouser and curiouser. 12 to the 12th. Even the calculator can't handle that. That's a really, really big number. Ain't gonna do it. That's me. Math rebel. Woot woot. Okay? When it says simplify each radical, that means your final answer, if it has exponents, will have radicals, not fractional exponents. But you want to think, what power is here? Squared, or the second root. So sometimes that works out great. What is the square root of 32? Do you get that that's not quite a nice problem? Because 32 is 2 to what power? 2 times 2 is 4. 8, 16, 5. That's 2 to the 5th. How many times does 2 go into 5? Twice. With how many left over? So you get to, and that's why I like dealing with letters, because I like that rule a lot better. What is 2 squared? So you can think about it as 4 square roots of 2. Do you mean to? Abso-freaking-lutely. And I prefer it that way because I make less mistakes when I do it that way than if I try to think, 32 is 4. 16 times 2 and the square root of 16 is 4. I do much better with this. I don't care how you do it. Whatever your brain says works, as long as it's the right answer. Go for it. Did anybody else do it the way I did? No? How did you guys do it? Just curious. So you did a perfect square times something. So you did the tree method? That's okay. I like 32 because I know that it's like one of my radicals. If you wanted to do the tree and say 32 is, 8 times 4, and that's 2 times 4, and you see, there's 2 2s, so I'm going to put 2 4s, so I'm going to write 1 on the outside. Or you can take it down all the way and say 1, 2, 3, 4, 5. You can do it the way I've got it. There are all sorts of different ways to handle this. I just know where my strengths and weaknesses are. I start looking at that, I get confused. I can understand 2 to the 5th, and I like 2 goes into 5 twice with 1 left over. However you guys work. But to finish this off, 2 goes into 7 3 times. With how many left over? 2 goes into 4 2 times. I am too tight here. X to the third y squared. None left over. 2 goes into 3 once with 1 left over. Do me a huge, and all of your future math teachers, a huge favor. Put a line through your z's. Otherwise, they look like 2's. I know. Crazy, huh? I totally get on this one, breaking this down by the tree way. Because I look at this and I think, okay, that's 2 times 27. 27 is 3 and 9, which is 3 and 3. So I go and I write this as 2 times 3 to the third. Everybody see what I'm talking about there? Because I have 1, 2. Those are the ends of all of my branches. I have 3 3s. And when I talk about the cube root of that, I say 3 goes into 1 how many times? Does it go into 1? No. So that means I'm left with the cube root with a 2 underneath. 3 goes into 3 how many times? Once. And then I'm going to go back to my letters. 3 goes into 9 how many times? 3, none left. 3 goes into 7. 1 left. 3 goes into 11. And there's my answer. Making sure you've got this little 3 going with your radical. How are we doing with this? So far, so good? Any questions on that? So we've moved from trig back to algebra. For this right here, the 2? No, square root is understood. It's kind of like saying divide by 1. You don't need it there. Okay? So if you want to put the 2 there, you can. You don't need that. So first semester trig was very much like geometry. What we're doing now is kind of going back to algebra. But that means that we do need a strong number sense in order to do this. Okay? These problems. You may not remember how to do them, but you probably remember getting them wrong. Yeah? Fair statement. Does anybody remember how to start this? Work inside the parentheses, because we're following our order of operations here. Everybody remember that? That's not going anywhere. So my order of operations, I do G for grouping instead of parentheses. Please excuse. So exponents and radicals pair up. Multiplication, division pair up. Addition, subtraction pair up. And you always work from left to right. So I start with my grouping. I start in here. I do my exponents and radicals first. So what is a 2 to the negative 1? 1/2. Good. What is 2 to the negative 2? 1/4. So I've done my grouping. I've done exponents. There's no multiplication or division. So now I'm going to do addition, subtraction. How do I add those? Common denominator. What would that common denominator be? So that would be how many fourths? 2/4 plus 1/4 gives me, and 3/4 to the negative 1 power, 4/3. If you stop yourselves, because everybody goes, oh, that's going to be 2 to the negative 3. Or, ooh, that's going to be 2 to the 1 plus 2 squared. If you stop yourselves and just do everything with the order of operations, you'll get the right answer. Okay? All right, and then there's 13. Lucky number 13. No. You don't need a calculator for this. Prove it? Is that what you're saying? The reason why you don't need a calculator with this, I know that 8 to the third is going to be icky. I don't want to worry about the square root of that. I'm already terrified. So what I'm going to do is I look at each of these numbers, 2, 4, and 8. Do they have anything in common? 2. I can write each and every one of those out as a factor of 2. So 2 squared, I'm not going to change. 4 is 2 to the 2 squared or 2 to the second. 8 is 2 cubed. Now, since I've gotten rid of all of those crazy different numbers, I'm just going to work this as if it was a standard variable type situation. I'm not going to change any of the 2's. I'm just dealing with their exponents. So it means I would have 2 squared times 2 to the 16th over the square root of 2 to the 9th. Yeah, the 9th. 2 squared and 2 to the 16 is 2 to the 18th. And you can deal with this a couple of different ways. I'm going to do with this as simplifying my radical. What is this power right here? 2 goes into 9. How many times? 4 times with 1 left over. So far, so good? And I'm just going to continue simplifying. What is that going to be? 2 to the 14th over the square root of 2. And then rationalize, bless you. So I would have 2 to the 14 root 2 over 2. And that will simplify one more step further and give me what? 213 root 2. Another way you could have done that is you could have said, all right, that's 2 to the 18th over 2 to the 9 halves. And what would you do with those two numbers? Subtract. So I could say 2 to the 18 minus 9 halves. So 18 is how many halves? What's 18 times 2? 36. And 36 minus 9 is 27. 2 goes into 27 how many times? 13 times with 1 left over. That's probably the trickiest one. There are multiple ways to do it, but the thing is you don't have a calculator, get everything to the same base, and then just work through your rules. Okay? Now, I'm going to give you a worksheet. This worksheet is front and back. There are a lot of problems on it. There are, because I don't know how to count, there are actually 58, because I skipped from 18 to 20, because you know, math. Actually, no, that means that there are 59. Some of these guys are going to go very quick. I mean, look at that. That's super fast. That's super fast. Some of these are super fast. What I'm going to do is I'm going to do this as both classwork and homework. So you guys are going to work through this. And then when we come back to class next time, I'm going to randomly select like, I don't know, 5 or 10 of these and grade those for accuracy, and the rest will be for completion. But ladies and gentlemen, next class, after I check over this, you are going to take a quiz that looks just like this warm-up. Different numbers, same skills. Okay? I've basically given you a practice quiz. right, so I'm going to give you your worksheet. You guys are welcome to work together. I would recommend, since you're working together, pick either all the odds or all the evens. That way you get a good variety of questions, and you can ask questions if you have them. But then to finish the homework is going to be, well, finish the worksheet is going to be your homework. And what else am I asking you to do? Bring your textbook. Thank you, guys.